Assalamu alaikum. We were discussing the topic data mining in our last lecture, and if you remember, I told you that data mining is the task of discovering interesting patterns from large amounts of data. This data may be collected, it may be stored in databases, in information repositories, in data warehouses. From all such information repositories or databases or data warehouses, this data is fed to the data mining tool. That is a special software. We develop that software, and then we apply this software to extract interesting patterns. And once we have these interesting patterns available, then we can, based upon this knowledge, we can then introduce some unique marketing strategy. We can come up with a unique marketing plan, etc. So data mining, in other words, has got a lot of useful application for businesses. Now, data warehouses are those information repositories where the data collected from multiple sources is stored, and here the data is in a clean, purified, integrated form, and this data is fit for data mining purposes. From data warehouses, the data is delivered or fed to the data mining tool for performing certain useful actions and to get certain useful patterns. If you remember, I talked about a term, knowledge discovery. Knowledge discovery is the process of getting useful knowledge. So a knowledge discovery process would involve different steps. So there would be data cleaning, data transformation, data integration, data selection, data mining, then pattern evaluation, and then knowledge presentation. So we can say that a knowledge discovery process includes all these different steps, and these steps, once they are accomplished, then we can say that we have gained useful knowledge based upon which we can perform certain useful things. So if you remember, I told you that data cleaning means that we want to supply missing values in our data. So wherever there are certain missing values, say in our databases, in certain rows, there are columns which have got no values, there are missing values there, so we can fill out those values then. So then we can say that we have cleaned the data. So in case in the column income there is no value, that column is blank for a particular row, then we can supply that value. We can see that what can be logically a value that can fit into that column. So that would be a part of data cleaning. Then there are certain instances where there are unreasonable or illogical values that are typed, and we have to get rid of those unreasonable, illogical values so that our data gets purified and there is no chance of any erroneous pattern emerging for us. So for example, in the age column in a particular row, if the value typed is 1000 years, that is an impossible, illogical value. So we have to get rid of that. As a part of our data cleaning job, we eliminate that erroneous value, so we can then provide some reasonable value, say 50 years, 60 years. What average value or reasonable value we find in the other rows, we use that as a basis to fill out the value and replace the erroneous value with a logical, with a reasonable value then. Then data transformation. In data transformation, we endeavor to convert all our data into one single format. So I gave you an example, say in the date column, if the date is typed as 15th December 2005 at one place, and at another place the date is fed or typed in a different format, say 15/12/2005. So we would want to make the format uniform. The date has to be in the single format. So this process of converting all our data into the same format is called as data transformation. Data selection is another task that we perform before we send the data for data mining. During data selection, what we do is that we identify all those different rows in which we find different missing values or erroneous values. So what we do is we eliminate all such tuples or all such rows altogether from our data. Because if we keep such erroneous data which has got so many errors, then there is a probability that our data mining results would not be very helpful. They would not be very precise. So this process of eliminating the entire rows or tuples where in different columns of such rows we are having missing values or erroneous values at more than one places, this process is called data selection. Okay, then data integration means that where we have different sources of data where we are collecting data. So we at the end integrate or assemble all such data coming from different sources. That process is called data integration. So data cleaning, data transformation, data selection, data integration, we perform all these different steps and then we send this purified, this cleaned, transformed, selected data into the data warehouses. So the data warehouses, they keep record of all such data which is now fit for data mining, and from there the data would be supplied to the system where a data mining tool would be installed, and that tool would then perform data mining operations on this cleaned data in order to extract certain interesting patterns for the users. Okay. Now, just to elaborate this concept that we can find out different interesting patterns through data mining, I want to give you an example. Assume that there is a company which has established different stores in different parts of the country. Say in various cities it has established different physical stores, and the data of the customers in all these different stores is recorded. There is an arrangement, special arrangement, whereby the data collected from the customers is contained in the databases. It is recorded in the databases. Then one fine day that company may decide that over a number of years now we have collected so much amount of data from different customers which is stored in different locations. Let us assemble all this data, integrate all this data, clean this data, transform it, select it, and let us apply data mining on this data to find out what exclusive interesting patterns they emerge out of it. Right? So if such a scenario exists and the company actually performs data mining on this collected data, which has already been cleaned, it has been made fit for data mining, then there is a possibility that the company managers, they come up with a peculiar pattern. They might find that customers coming from a particular location, having a particular income level, and within a particular age bracket, for instance, they are the ones who have shown inclination or propensity to buy computer-related items. Now, this is a very useful piece of information. applying appropriate data mining tool on the data collected, there is a special pattern which is emerging, and it indicates that there are certain customers who have a particular age group, who have particular income level, they come from particular geographical location, and they are the ones who have persistently shown their exclusive interest in computer related products. So this is a very useful piece of information for marketers for that company. In case that company in the future decides to launch any computer related items and it wants to market that future product, computer related product, then these customers who have shown inclination to buy computer related items, they are to be targeted first. So what the company managers, the marketers, they should do, they should try to focus more on the persons whose profile has been provided, whose exclusive pattern has been supplied by the data mining tool. So the managers, they should focus on the customers coming from a particular geographical location, having a particular age group, and having a particular income level. They should focus more on such customers because these are the ones who are likely to respond. The point I'm trying to make is that instead of wasting your energy, your money, your time on marketing your computer related items to people at random, it is much more appropriate that you focus on the pattern that has emerged through data mining. You target those customers having a particular profile who have in the past shown their inclination to buy such products, because these are the ones who are going to respond. In this fashion, you can save money, you can save your time, you can minimize your effort. Okay, so when I say that you can reduce your cost, I mean that the cost for sending mails, direct mails to the people, that would be reduced, because you would not be sending mails to public at large. You would not be sending your mails at random. Rather, you would be very focused. You would just be sending mails to the appropriate relevant people, those who have shown their inclination to buy such products. So I hope that I'm making sense. It's a little complex, but I hope that with the help of the example I'm going to show to you, you will be able to understand this. Now, first of all, I want to show you two diagrams that would elaborate the knowledge discovery process. So let's have a look at the slide. On the screen, you can see there are 4 different sources where data of a company, of a business is being collected, is being stored. So there is a data source in Karachi, for that matter, then a data source in Lahore, data source in Islamabad, data source in Faisalabad, and the company on these different locations, it gets the data input provided by the customers, it records this data in the databases, for that matter, and then this data is cleaned, transformed, it is integrated, and then it is loaded to the data warehouses. So data warehouses is that place where cleaned, transformed, integrated data is residing, and from there the data can be supplied to the data mining tool which is installed on the client machines, and then the clients, they can perform certain queries, they can do the analysis. By applying the data mining tool, they can extract certain patterns, and based upon those patterns they can discover some useful knowledge. This is the diagram on the screen which shows the stages in the knowledge discovery process. So in the first stage, at the bottom, we have databases where we collect the data, and then cleaning and integrating this data, we then send it to the data warehouses. Some selection and transformation of the data can also take place in the data warehouses. From the data warehouses, the data is shipped to the data mining tool for data mining purposes. The data mining tool can provide us certain useful patterns, say useful graphs, tables, decision tree. In different graphical ways it can give the output to us, and these patterns, they can be evaluated, they are presented to the managers then viewing these patterns and analyzing these patterns, they achieve useful knowledge, they get reinvigorated. Now based upon that knowledge they can embark upon some unique business plan, some different marketing scheme, etc. There are 4 main types of data mining. So you can see on the screen also there are the 4 types: classification, association, characterization, and clustering. We'll deal with them one by one. I just want to give you a broad concept because we do not have enough time during this course to understand all the algorithms associated with each type of mining, but I just want to give you a broad concept so you have an understanding how we can apply these different data mining techniques to our businesses. What is the main concept? Now, classification and association, these 2 types, they are predictive type of data mining, which means that when we extract certain patterns through classification and association, we can predict certain things based upon the knowledge. These are predictive type of data mining. Conversely, the characterization and clustering, these are the descriptive type of data mining. We are just interested to understand the general behavior of the data in the last 2 types, characterization and clustering. In classification, we attempt to label certain samples onto certain classes. That is the main function we perform through classification mining. So I elaborate this. Where we have some data and we apply the classification mining on that data, it is possible that we discover a profile. We keep this profile before us, we keep this pattern before us. Then in the future, if any sample, any information about a customer comes before us, and we want to identify, we want to know certain information about that customer which is not available to us in the sample that has now come to us, we can predict that information based upon the profile that we had earlier extracted. Right? So that means we can label the information or a sample regarding a customer onto a particular class. So we can say that this sample has come to us and we want to know what is the sex of this customer. Is he a male or a female? Based upon earlier pattern, we can then say that this sample, this customer is likely to be male. We can classify this particular sample now to the male class. Okay, so in this way, in classification, we label different samples, different customer information onto different classes based upon the earlier collected data. The result of classification mining is if-then rules. So there will be certain if-then rules that would emanate as a result for classification mining. These if-then rules are more conveniently displayed in a graphical format with the help of decision trees. Decision trees are tree-like shape, basically, which express these if-then rules in a particular format. Okay, there are 2 major algorithms which have so far been implemented for classification mining. One is ID430 algorithm and the other is Bayesian classification theorem or algorithm. I'm not going to take you into the details how these algorithms they function, what is their logic, because that would be too complicated. I just want to tell you that these are the 2 main algorithms which can be implemented to perform classification mining. Now, I can show you a slide here that would show you a decision tree. So you can see at the top there is a box, and in that box there are the two classes, male class and the female class. I represent them with M and F. When we have tons of different data, cleaned, purified data in our data warehouses, we supply this data for classification mining to the data mining tool. The first thing that we have to indicate to the tool as to in what ratio we want to split this data. So we have to, as a first step, bifurcate or split this data into two types of data. One is called training data and the other is called test or validation data. So we can indicate to the tool, for that matter, that we want to split this total data coming from the data warehouses into 70%, 30% ratio, or say 60% or 40% ratio. Okay, then the data mining tool doing classification for us can find out that if no profile is generated, if at random any 100 tuples or rows are picked, there are 55% chances of being male. So out of any 100 tuples in the sex column, there are 55 males and accordingly 45 females. This is the situation in case of training data. Say we have allocated 70% of our total data to the training data and the rest 30% data to our test data. Now the test data corresponding to 30% of the total would also be checked by the data mining tool, and it may discover that in 100 tuples under the sex column there are 56 males reported, and in the sex column accordingly 44% females are reported in the test data. So normally where the difference between the training data and the test data is just 1 or 2%, then that means that that rule is effective and it can be treated as a valid rule. So this is the situation at the top when we have no application of any model. At random, when we select the data and we check the data, we find about 55% males and 45% females. When we apply the data mining tool for classification, the data mining tool, say ID3 algorithm, may find out that, well, age in this all data is that particular variable or that attribute which has some significance. So if age of the individuals is between 20 years to 25 years, if that is kept as a standard, then in all the corresponding columns, the number of males becomes 60 in any 100 tuples. So the ratio of the males becomes 60%. If age is to be taken as a factor for determining the males or the females. Then further, the data mining tool may also find out that education is yet another variable or a predictor. So if the education level of the customer is metric or below, it finds out that the probability of finding males increases from 60% now to 62%. And also correspondingly the test data also provides almost the same result with a 1 or 2% variation. So in case of age, you see where males 60%, in the test data we have the percentage 59%, and for females 40%, the test data correspondingly has 41%. Similarly, in case of education, when the training data shows 62%, when the education is metric or below, the test data correspondingly shows 64%. And for females, 38% for training, and 36% for test data. So with a variation of 1 or 2%, the figures about the training data and the test data would be calculated. And the purpose of bifurcating or splitting this data into training and test is that we want to determine the effectiveness of our rule, right? So if the variation is just 1 or 2%, that means that our rule is effective. Our rule that age 20 to 25 years, then male 60%, that rule would only be effective if it is corroborated or confirmed by an independent set of data, that is test data. If the test data with the variation of 1 or 2% almost provides the same figure, then it means that this rule is effective. It should be taken, it should be displayed. That is the purpose of splitting the data into training and test data, because we want to confirm the effectiveness of the rule. Next, after education, the data mining tool may also find that annual income is yet another variable, and if the annual income of the individual is less than 1 lakh, then the percentage of males in the relevant rows, it becomes 65%. And this is also confirmed by checking it in the test data, and if the test data says it is 66%, there is just the difference of 1 degree, then it is acceptable. This rule is also displayed then. Similarly, for females, 35% for the training data and 34% for the test data, and this can continue. The ID3 algorithm may find out other predictors, other variables also, that can improve the percentage of predicting males or females. On the other hand, on the right side, you can see that there can be a possibility that location is figured out as a variable to predict females. So location, if its value rural areas, then males 40%, females 60% in the training data, and in the test data, males 39% and females 61%. So there is just a difference of 1% in the female category, 60%, 61%. So therefore, this rule is effective. It has been confirmed by the independent data, that is the test data. Therefore, it can be presumed that this rule would be valid for all different types of data. It should be taken, it should be displayed. Secondly, marital status can prove to be another factor. Marital status, if unmarried, then males 35% and females 65% in the training data, and in the test data, males 36% and females 64%. So you can see that in this fashion there can be a particular pattern that would be evolving in relation to females. And there can be other different variables. I have just confined myself to these few variables. There can be a variable called religion, a variable called profession, and so on. All these different variables would be checked by the algorithm. The algorithm would be specifically designed on such basis that it would find out as to what are the best predictors, what are the variables which it has to figure out, which it has to use to increase the probability of predicting males or females, as the case may be. So in this particular example, you may have noticed that there is a particular pattern which the tool has generated for us. This pattern is that if age is between 20 years to 25 years and education is matric or below and income is below 1 lakh, then there is 65% probability that the individuals would, their sex would be male. Okay? So in case we do not apply this model, we do not rely upon this pattern or this profile, we just at random pick any 100 tuples and see how many males we find, we'll see that there are 55 males. In any 100 tuples or rows in the sex column, we find 55 males. This is at random. But in case we apply the tool and we follow a pattern, that is the pattern which the tool has provided to us, we follow a particular age group, we follow the education, we follow the income level, the information which is provided to us, then in every 100 tuples, the value in the sex column would be male in 65% cases. Okay, so we have increased the possibility of reaching our target attribute from 55% to 65% by following a particular pattern. And again, I repeat, we split this data into training and test data because we want to judge the effectiveness of the rule. If a rule is generated, if age is proved to be a particular variable which can predict certain things, and if the other set of data, test data, also finds that age is the right predictor, if both training and test data indicate the same variable to be a predictor, then that rule would be taken for displaying purposes. That would be considered as an effective or valid rule. Okay, now just imagine that if we want to target male population, if we say have discovered, if we have manufactured, say, a perfume which belongs to the male category, which relates to the male category, and we want to target the male population in relation to that particular perfume, then instead of wasting our energies by sending random messages, we should follow this particular profile, this pattern. We should follow this age group, we should follow the education level, we should follow the income level, because if we follow this profile, this pattern, our probability of reaching males increases from 55%, which is at random when no model is used, from 55% to 65%. In light of this profile, in light of these rules or this pattern, when we actually launch our marketing campaign and we send the mails or marketing messages to the individuals which correspond to this particular pattern or profile, we may find that out of 100, just 50% they prove to be male. So that is our actual result. Out of 100, we were able to reach 50 males. We wanted to reach males and we reached 50 males when we applied this particular model, that is age, education and income. We just confined ourselves to these three variables. On the other hand, theoretically, the model had predicted us 66% males. If we follow the model, the profile, the pattern, then we should have reached 66% males. Remember, this figure 66 is in relation to the test data. Okay, for calculation purposes, for the calculation of efficiency of the model, we take the figure which is there in the test data. In the training data, this figure is 65%. In the test data, this figure is 66%. When you look at the income variable, income less than 1 lakh, you will find that 65% is for training data, 66% is for the test data. For calculation purposes, you use the figure which relates to the test data. that is 66. So now you can look at the slide. Efficiency of the model is actual divided by theoretical multiplied with 100. So if the actual figure is 50, if we use the model, then we find that actually 50 persons, they prove to be males to whom the mail was sent, divided by 66, which was predicted or provided by the model, as you saw. So 55 over 60 into 100, that is 75.75%. That is the efficiency in percentage of this particular model. Okay, so wherever the efficiency happens to be above 70%, 75%, etc., we can say that this model is useful. We can make use of this model. It does effective prediction for us. We can apply or utilize that for our business purposes. In case this ratio of efficiency, this comes to be 50%, 60%, that indicates that this model perhaps is not that useful. We need to improve perhaps the cleaning process of our data. Maybe there are certain errors in our data which we supplied for data mining purposes. We may want to improve the condition of the data. The data needs more cleaning. So there can be multiple factors for a poor efficiency ratio. But wherever it is above 70, around 75%, you can say that this is a useful model. You may want to apply it for any marketing campaigns. Here, let me point out one thing. The data cleaning process consumes most of the time of the total knowledge discovery process. So according to an estimate, about 80% of the total time which is required for achieving useful knowledge after data mining, that 80% of the knowledge total knowledge discovery time, that is consumed in data cleaning activities. Right? So the main job is that you clean the data, you transform the data, you integrate the data, you select the data. Okay, in this fashion you make the data fit for data mining purposes. Once your data is cleaned, purified, is fit for data mining, then there is a probability that your data mining results would prove to be useful, they would be effective. The data mining job would be performed in 15-20 minutes. You supply the data to the tool, it can generate the results or patterns for you, say, in 15-20 minutes. Most of your time is consumed in making the data fit for data mining purposes, in cleaning the data, in removing the erroneous values in the tuples, in the rows, or providing certain missing values. So as I mentioned earlier that about 80% of total knowledge discovery time, that is consumed in just data cleaning, data transformation activities, etc. I also want to give you another example in this regard in relation to classification mining. Say if there is a sales campaign and there are 3 different classes: good response, mild response, no response, and there are different variables like price, brand, category, then it is possible that our data mining tool may find price to be that single predictor or variable which best distinguishes different tuples in these 3 different classes of good response, no response, or mild response. So as you saw in the previous example, there were 2 classes, male class and female class, and here in this example there are 3 classes: good response, mild response, and no response, and based upon certain variables, predictors, which would be found out by the relevant tool, we can then classify different samples into these three different classes accordingly. The next type of data mining is association mining. So association rules can be discovered by the relevant algorithm, and they can show that there is certain propensity, certain inclination between the items to occur together, or there are certain values of the attributes which occur together frequently in a given set of data. So we use this association mining mostly in market basket analysis. Just to elaborate the concept, I can give you an example. Say there is a huge shopping store where there are a number of items placed for sale, and that store has made an arrangement for the recording of the data, so the customer information and the items which the customers purchase, all that information is in a routine manner recorded in the databases by that store. So over a number of years, that store managers, they find that, well, we have collected now a lot of data, we should apply the association mining tool on this data and to see what is the pattern that we come up with. So it is possible that on applying the association mining tool on that collected data, they find out that there are 80% chances that when eggs are sold from this shop, milk is also sold together. Or when the books are sold, the computers, they are also sold along with, etc. So this is a very peculiar information. It has got a lot of significance. It is of an immense value for the store, that they are able to identify as to what different items they have a level of affinity or closeness or a strong relationship among themselves. And then based upon this knowledge, on this clue, they can come up with different marketing schemes, they can identify different promotional mechanisms, etc. The algorithm which is used in case of association mining is called a priori algorithm. I again don't have time to teach you the basis on which this algorithm is built, maybe in some other course, but for the time being I just want to give you a broad idea, just to have you this idea that how association mining can help us in our business. There are two measures which are used in relation to association. One is confidence and the other is support. These are the two terms which you should know in relation to association mining. Confidence means that how often is the relationship true. In other words, what percentage of the time when people buy a particular item, they also buy another type of item. Again, in simple words, what is the level of closeness, association or affinity between two items? So that ratio is confidence. On the other hand, support refers to the probability of having a particular combination in overall transactions. So what is the probability that this particular combination of items that would be sold in a day, that would indicate the support. I want to elaborate this idea, so you can look at the slide. You can see confidence is equal to transactions. As an example, I have taken the example of eggs and milk. So all those transactions in which eggs and milk both are sold together, divided by transactions in which either eggs are sold or just milk is sold or both are sold. When we take the ratio of these two things, the result we get is confidence. For example, there are 25 transactions in which eggs and milk are sold, and there are 75 such transactions in which either eggs or milk or both are sold. When we divide 25 by 75 and multiply with 100, we get 33.3%. So that indicates the confidence, which means that eggs and milk, they have this degree of relationship, this degree of closeness or affinity between them. There are 33.3% chances, in other words, that when eggs are sold, the milk would be sold together, or vice versa. So confidence is basically to indicate the closeness between the two items themselves. On the other hand, support, you can see, is equal to transactions in which eggs and milk are sold together divided by total number of transactions. So if in a day there are 10 such transactions in which eggs and milk, they are sold together, and there are total 50 number of transactions in a day, when we divide 10 by 50, multiply with 100, we get 20%. So the value of support in this example is 20%. That means that there are 20% chances that in a day eggs and milk would be, this combination would be sold together out of a total number of transactions that are carried out in that day through that shop. Now here I pose a question to you, just in case there is 90% confidence and there is 5% support, what inference you derive out of it? What do you gather out of it? Okay, I repeat, there are two items which have 90% confidence and the support level for these items is 5%. What do you make? The answer is, there is no doubt a very strong degree of affinity or closeness between the two items. There are 90% chances that when one particular item would be sold, the other would also be sold. The chances are 90%, very good chances. But on the other hand, since the support is just 5%, which means that the probability of these two items being sold out in a day out of total number of transactions is just 5%. People come to do the shopping, they buy other combinations, other items. There are just 5% chances that they would buy this particular combination. Although it is true that whenever they would buy one particular item, there are 90% chances they would also buy the other item. But the probability of occurrence of this combination is just 5%. So as a marketer, you have to very closely and carefully look at both these values, confidence and support, to make your marketing decisions. Then we can also adjust these figures, these measures, so we can set different values. We can specify that confidence 40%, support 50%. So against these two values, 40%, 50%, which we ourselves specify to the tool would in return, in response, provide a list of all such items which fall according to this criteria. So it would supply us all that list which are in conformity with the values that we provide. So in this fashion, we adjust different values of support and confidence, and the tool would provide us the list of all those items which fulfill this criteria. So that was mainly about the association mining. We have to discuss the other two types of data mining techniques, that is characterization mining and clustering, about which I talked in the start of the lecture. Let's summarize what we have done so far in our today's lecture. We have studied again the definition of data mining. Then we have seen what are the various types of data mining, what is the concept of classification mining, what is the concept behind association mining, what are the algorithms which are used in relation to classification and association mining. Both these, classification and association, they are predictive type of data mining. In our subsequent lecture, inshallah, we shall carry our discussion forward on this topic, data mining. Till then, Khuda Hafiz.